Let's walk through the Generative AI Learning Roadmap, a structured path designed to guide anyone from the basics of artificial intelligence to building sophisticated generative models and AI agents. First, we ask, what is generative AI? At its highest level, AI is a broad field dedicated to creating machines capable of performing tasks that normally require human intelligence. Within AI, machine learning uses algorithms that learn from data, and nested inside that is deep learning, which relies on artificial neural networks to identify patterns. Generative AI is a subset of deep learning, models that don't just recognize or classify information, but actually generate new content, whether text, images, audio, or code, based on what they've learned from existing examples. Before diving into model architectures, it's essential to master a few core mathematical concepts. You'll need a solid grounding in probability, so you can understand how models quantify uncertainty. Linear algebra, since vectors and matrices lie at the heart of neural network computations. Calculus, which underpins optimization and gradient-based learning. And statistics, which helps you make sense of data distributions and model evaluation. Metrics. Together, these four areas form the mathematical foundation for pretty much all of generative AI. Once you've built up that theoretical base, you can begin exploring foundation models, pre-trained neural networks designed to handle large-scale generative tasks. Examples include GPT, one of the earliest transformer-based language models, Llama, Gemini, DeepSeek, and Claude. Each of these models has been trained on massive text or code datasets, and can be fine-tuned or adapted for downstream applications, from chatbots to text synthesis to code generation. But you can't train or fine-tune those models without the right Gen AI development stack. On the software and tooling layer, you'll typically work with languages like Python and frameworks such as LangChain for chaining model calls, ChatGPT's API for direct interactions, and libraries dedicated to prompt engineering. For data storage and retrieval, you might leverage specialized vector databases, and for specialized downstream tasks, you'll find open-source tools like DeepSeek, Metal Llama, and the Hugging Face ecosystem invaluable. This stack gives you the building blocks for working with large volumes of data and interacting effectively with foundation models. Bringing those elements together, you next move into training a foundation model. This process starts with dataset collection, where you gather, clean, and pre-process text, images, or other modalities. Next comes tokenization, which converts raw text or code into tokens that the model can understand. During configuration, you select hyperparameters like learning rate, batch size, and model depth. You then run training loops on high performance hardware such as GPUs, or even specialized accelerators, periodically evaluating the model's performance on held-out data in the evaluation stage. Finally, once you're satisfied with your metrics, you proceed to deployment, integrating the model into a production environment or serving it via APIs. Once you have a trained foundation model, the next frontier is building AI agents, autonomous systems that can perceive, plan, and act within an environment, sometimes with human oversight. An AI agent combines a few key capabilities: reactivity, to respond in real time to new inputs; memory, so that it can store and recall relevant past information; autonomous action, where the agent takes initiative based on its objective; and human control, which allows people to intervene or adjust high-level goals when needed. Under the hood, agents use tools such as API calls, the ability to interpret code, and internet access to fetch data. Those tools enable the agent to delegate tasks, like querying a database, calling external services, or even writing and executing code to achieve more complex goals in a dynamic environment. For those interested in generative AI models for computer vision, you'll explore a different category of foundation models specialized in images. GANs, or generative adversarial networks, pit a generator and discriminator against each other to produce realistic synthetic images. Midjourney and DALL-E are well-known proprietary systems that use transformer or diffusion frameworks to generate artwork and photorealistic images from text prompts. Flux is an example of an open-source or research-focused vision model. These models can generate new images, edit existing photos, or even produce video sequences, all by learning the statistical patterns of pixels in large image datasets. Finally, to continue your growth and stay up to date, you should tap into generative AI learning resources. DeepLearning.ai offers online courses that cover both the fundamentals and advanced generative techniques. Kaggle provides datasets and competitions where you can apply generative models in a hands-on way. Google Labs frequently releases research prototypes and interactive demos that allow you to experiment with new generative algorithms. NVIDIA Learning publishes tutorials, webinars, and sample code for training large models on GPUs. And for a systems-level perspective, the Gen AI Insider's Guide by ByteByteGo walks you through the end-to-end process of designing, building, and scaling generative AI systems. By following this roadmap, starting with foundational math, moving onto pre-trained models and the necessary development stack, then learning how to train your own models, build intelligent agents, and leverage vision-centric generators, all while tapping into community resources, you'll be well on your way to mastering generative AI and applying it in real-world projects.